Hello everybody, this is our third standing tree measurements lecture. Today we'll be discussing basal area, and the whole idea with discussing basal area is when we look at a couple pictures like this, and if we're in the forest like this young lady on the left, and we see what's in front of her, or we see what's in front of us if we're standing in the picture on the right, how do we know what that means? We see a bunch of trees. We know that based on what we've learned so far, we can measure their DBH, so we know how wide the trees are, and we know their height. But how do we take those measurements, or how do we start using those measurements and really start saying how much we have out there in the forest? And that's where a measurement like basal area is going to come into play. And so when we're talking about basal area, our definition of basal area is the cross-sectional area of the stem at DBH. So if you're saying the basal area of a tree, you're saying that that tree has X number of square feet. And so we're talking about this idea that if we were looking at an individual tree, 4.5 feet or 1.3 meters up from the stump, we'd be saying this area right here. And so why we want to know that is we want to know how much space the tree takes up, because then once we get to stand basal area, so individual tree basal area will get us to stand basal area, which is going to be important in terms of inventory and then management, because really being able to say that this tree is X number of square feet isn't as important as being able to say that this stand of trees is X number of square feet per acre, because now once we can take something and put it on a per acre basis, we make it comparable. And when we make it comparable, now all of a sudden we can say, well, this stand was 100 square feet of basal area. This stand is 50 square feet of basal area. This stand is 220 square feet of basal area. And now we start to have a comparison. Now we start to have a number that we can really start to use and look against each other. The idea of individual tree basal area, though, becomes important in the idea of stand basal area, because the size of the tree is going to be important in this whole thing, because we talk about a per acre basis for a lot of this stuff, and so we need to know the size of each individual tree to know how much wood is there, and then the idea of how much wood does each one of these trees take up in an acre. So when we look at it, we're going to go out into the woods and we're going to see things like this. You're going to see a bunch of trees. Maybe if it's more of a plantation, you see a lot of trees of the same size, or if you're not in a plantation, lots of trees with lots of different sizes. But if you look here on the right, what we're doing when we're talking about basal area is we're saying how much space does that individual tree take up and how much wood is in that individual tree, because if we've got this idea of how much square feet that tree is taking up, and we have height, if we have square feet and we have height, then we have cubic feet. If we multiply those things together, now we have volume. And so then if we have the volume of the trees, now we know how much space these trees are taking up, how big these trees are, and we can put that all on a per acre basis, and then that's really going to help us make management decisions in terms of how much light does the stand get, how much shade is going to end up on the ground, how much competition is there, how much understory growth do we want, and how can we manipulate the trees, how can we get rid of some of the trees, or what we call thinning. And it starts to allow us to make all these different management decisions. But we need to know this idea of how big these individual trees are, and then apply it to, well, how much space does that tree take up, and then all of the trees around it take up within this stand, to really then be able to manage the stand and manipulate the stand correctly. So this graphic to me here is extremely important in the understanding of the idea of basal area per acre versus something like trees per acre. When we do an inventory, we're really interested in the size of the trees because we want to know how much wood is out there. And so if you look at this graphic here, each one of these black dots is a tree. So in this top left, it's 6-inch trees, and those are all 6-inch trees. In this top right, you've got 10-inch trees, each one of those black dots. Bottom left, 18-inch trees. Bottom right, 14-inch trees. Okay? Now, if you're looking at a number like trees per acre and just thinking with the basic idea how much wood is out there, you would think that there might be more wood out there because there's so many more trees up here than there are down here. But then, because we understand DBH, we start saying, well, whoa, these trees down here, these are 18-inch trees and these are 6-inch trees. So these trees are 3 times as big as these trees, and this tree's almost half as big, 1.5 times these trees here. And so when you start thinking about it that way, then it seems like we should come up with some sort of a better number to use that, because the trees per acre is not going to give us the number that we need in order to really understand the difference here, but basal area might. And what's interesting is if you read down here, you've got 6-inch trees, 10-inch trees, 18-inch trees, and 14-inch trees. All of these plots here, they all represent 60 square feet of basal area. So in 6-inch trees, that's how many trees would make up 60 square feet of basal area. 10-inch trees, 60 square feet of basal area. 14-inch trees, 60 square feet of basal area. 18-inch trees, 60 square feet of basal area. So why basal area becomes a really important measurement is if we're really concerned with how much wood is out there and how much wood can we get from these trees, basal area gives us a much better representation of that than trees per acre. Because trees per acre, you still have to know the size of the tree to really be able to tell something from trees per acre. And with basal area, we don't need that. All you need to hear is 60 square feet of basal area per acre, 100 square feet of basal area per acre. And what you start to do is, as you learn and take those measurements, you start to train your eye as to what does 60 square feet look like. And you'll get used to this idea of 60 square feet in small trees or 60 square feet in big trees, and really start to get used to it. But instead of having to use multiple numbers, we've come up with basal area as this one number that really helps us figure out how big the trees are in terms of their size. And so there's 2 ways to calculate basal area. The idea that we would take the DBH of the tree, and then we're just going to apply a mathematical formula to help give us the size of the tree based on the idea of circumference. And then but like we've said before, we're really interested in the idea, let me move myself up here. We're really interested in the idea of basal area in terms of the amount of basal area per acre for the stand. So we're going to do that when we do inventory, and we're going to calculate it by plot. And so let's go over the basal area formula. Move myself over here. So the idea of basal area simply comes from the idea of the area of a circle. Now, the one thing that we can't really account for, other than in the tools that we use, is stem irregularity. So the idea that we're gonna just assume a perfect circle. We understand trees are not a perfect circle, but that's the best assumption that we got. Now, if you make sure that you're measuring with a DBH tape, whether that's on a logger's tape or it's just a specific DBH tape, that's going to measure around the tree, and that's going to kind of set into those grooves and measure those around those deformities or stem irregularities. So we're going to get a pretty decent measure of the amount of wood within that tree using the basic geometric formula. So we take the area of a circle, which is pi r squared, and we adjust it a little bit. We say instead of r squared, because we don't measure the radius, we do measure the diameter. So we know that the radius is just the diameter divided by 2. So if I do that, and I say, all right, the diameter divided by 2 squared times pi gives me the area. Well, now what if I, the idea is though that I don't measure that, I'm doing a feet. I have basal area being calculated in feet, in square feet, but diameter is being calculated in inches. So I need to change that. And so I'm going to get 12 in there, and that's my conversion from inches to feet. And so in order to do that, I'm going to look at that now to change this here, because we went from diameter divided by 2 to now diameter divided by 2 times 12 for our conversion squared. So now we've got pi, which we'll take it out to 3.14159.264. You can keep going if you want to. Probably you're good enough at 3.14, or if you want to be even more exact, 3.14159. And then if we square all that stuff, 2 becomes 4, 12 becomes 144, and then times whatever our diameter that we get. So if I take 3.14159.2654 divided by 4 times 144, I get 0.005454154 times d squared, or what we have simplified our basal area formula for. Basal area equals 0.005454 times dBH squared. Now this is a number that as a forester, as a person working in the outdoors, you just need to know, and you need to have memorized, and you need to understand just the idea of that's how we calculate basal area. Do you need to know how to go from a circle to there? Not really. That's what I was here for, to tell you that, but you need to know that formula and have it memorized. I have literally been at forestry conferences where older foresters meet younger foresters, and they'll shake their hand and introduce themselves, and then the first question out of their mouth is, how do you calculate basal area? So it's just kind of one of those things that as a forester you're expected to know this formula, 0.005454 times dBH squared. So let's take this and let's put it into an example here. So we know we're going to measure dBH. We know we want to get basal area, which is this cross-sectional area at dBH. And so we take our formula, which is 0.005454 times dBH squared. Let's say this is a 12-inch tree, so we take our tape, we measure around the tree, we put it together, and it landed on 12.0. Or if we're using 1-inch classes, maybe it landed on 12.3. We called it a 12. So then we take our formula, 0.005454 times 12 squared, and that gives us 0.079 or 0.8 square feet. And so this tree, if it's a 12-inch tree, this area right here is 0.79 or 0.8 squared feet. But when you hear a measurement like that, because it's just the one tree, it's good. We know how much space that tree is taking up. It takes up 0.8 squared feet, but really it'd be more interesting if we knew how much space all of the trees took up, because then we could start saying, well, we take all that plus all the height, or times all the heights, and then we know the volume, and then we know how much wood is in the stand, and then we can really have numbers that are very useful. And so the averaging dBHs. So if we're going to start looking at all of these things together, what we found is that there's a measure called quadratic mean diameter, which actually represents the average of these dBHs better than if we just took an arithmetic average of the dBH. So when we say the term quadratic mean diameter, what we're actually saying is that it's a measure that represents the diameter of the tree of average basal area. Now remember, the size of the trees is extremely important, because we're still trying to figure out how much wood is out there in the forest. And so through a lot of work, a lot of people before us has figured out that if we can base the DBH on the size of the trees rather than the arithmetic average, it's better because we know that trees are usually of different sizes, and the size of the tree is what's most important to us. So quadratic mean diameter is a better measurement than the arithmetic average. So what's the difference? So here's the formulas. So if we were just saying that we wanted to get average DBH, we'd take all of our DBHs, we'd sum them up, and we'd divide by our number of trees. That would give us our average DBH. With our quadratic mean diameter, instead, we're going to get our average basal area. We're going to take the square root of our average basal area divided by 0.005454, which is just taking that our formula and kind of reworking it, and that gets us our average DBH of. But when we say average DBH this time, it's the average tree diameter for the tree of average basal area. So let's look at kind of a difference. So if we take a look at an example, we see right here in figure 1, and this is in this technical note, so if you want to pause the video and read through the whole note, you can follow the link here. But they show two graphs here. One is for a 5-year-old poplar plantation, and the other one is just for what they consider more typical inventory data. But you can see they've got their median DBH, which is 3.5, their arithmetic mean DBH, which is 3.57, but then their quadratic mean diameter is 3.64. If we look at the graph on the right, median DBH is 17.3. Your arithmetic mean is 17.67, but your quadratic mean diameter is actually 19 inches. So it's really interesting to see. And when you kind of look at the numbers here in the chart, the idea that that the numbers can vary quite a bit. The difference between thinking that the majority of your trees are 17-inch trees versus the majority of your trees size-wise are 19-inch trees, there could be a dollar-wise difference between that depending on how big of a piece of land we're talking about. Maybe this is a small amount of error. Maybe it's not that big a deal. Maybe it's thousands of dollars worth of error. And so it's really important to just to understand that they have worked through the idea that QMD, quadratic mean diameter, is a better measure when we're talking about the size of your trees on average. So if we work through our own example, so what I would say to you is look at these numbers here. So we got stand 1 and stand 2. So what I want you to do is I want you to work through the numbers for stand 1 and take those average DBHs and do a regular averaging. So take all those numbers, add them together, divide by 5. Then what I want you to do is I want you to actually calculate the basal area for each one of them. So that's 0.005454 times DBH squared. So the steps are going to be step 1. Calculate the individual basal area for each tree. That's going to be using our formula. Step 2, average your tree basal areas. Step 3, plug it into the QMD formula, which is QMD equals the square root of your average basal area divided by 0.005454. What I'd like you to do now is pause this video and work through those numbers for both stand 1 and stand 2. And so you should have come up with these numbers if you do the arithmetic average and you do the QMD formula. You should see that stand 1 has a difference of almost about half an inch, in terms of the QMD, whereas stand 2 has almost a whole, or has over a whole inch of difference between the average diameter and the QMD. So there is a difference between just averaging, getting average T diameter versus QMD, which is based on basal area and is a much better measure with us for us in terms of looking at the size of the tree. And so how do we put all this into inventory? And how do we, when we look at this picture on the left, how do we say, oh, well, that's something like 50 square feet, 60 square feet of basal area, and looking at these trees per acre numbers for all of our different basal areas depending on the average size of our trees. And how do we know when we just look out here in the forest at these spots that that's going to tell us useful information? Well, the big thing about it is getting everything on a per acre basis, so that we can say things like in this picture right here where it says on the left, a burned pine stand with a basal area of 110 square feet per acre and little herbaceous cover versus a burned pine stand with 90 square feet per acre. And you can see the difference in the herbaceous cover because of the difference in light that can come through the canopy. And so if we understand, if we get used to calculating basal area, then we can really start seeing these differences between, okay, that's what 110 feet looks like, that's what 90 feet looks like, this is what 60 feet looks like, this is what 50 feet looks like, this is what 250 feet, square feet of basal area would look like. We start training our eye to be able to really be able to start getting our eyes to match up with what the numbers say, and really start to get this feel for how to do inventory and what a forest stand looks like. And all of a sudden, for me, at least with basal area, I go from just like, okay, well, DBH, I measure the width of the tree, and height, I measure the height of the tree, so I know the width and the height of this tree, to more of with basal area, this is how much wood is actually in this tree. This is how much wood is in this forest. If I took out 20 square feet, this is how much less wood I would have in this forest, but then this is also how much light can come through the canopy, and this is the increase we get in herbaceous ground cover if wildlife is something that's important to us. And we really start having this measurement that that is very comparable and allows us to really start making management decisions. And so if that's the case, how are we going to measure basal area to get stand basal area? So we're going to use a few different tools. So we first have to figure out how many trees are going to be in our plots. Now we're going to go into plots in detail in inventory in the next few lectures. So I'm just kind of quickly going over the basic idea, but you're either going to use an angle gauge or prism, which is what we're about to talk about in the next slide, and you're basically going to hold that that instrument out with one. You're going to hold the instrument over plot center. With the other one, you're going to hold your own eye is going to be over plot center. So with the angle gauge here, you're going to stand at plot center. You're going to hold the angle gauge out from plot center, and you're going to use a certain basal area factor. So what that means is that, for instance, here on the right, this is a basal area factor of 10. That means every time a tree is in, you're going to count 10 square feet. So right here, this is in because it fills up the hole that's on this piece of paper. This is out because I can see that it doesn't fill up the hole. That's definitely out. This one, if I'm not totally sure that it does, or one of the edges might be on it, then we call it borderline, and we have to have some sort of a process to say whether it's in or out. But then I'm just going to take whatever number of in trees I have. Let's say there were 5 of them. They're 10 square feet apiece. That means that plot had 50 square feet of basal area. 10 square feet times the 5 trees. So that's a basal area factor. Angle gauges, like this one being used here, actually has different measurements on it, so you can choose from 5, 10, 20, or 40 square feet. depending on which one that you choose. Now with a prism, the prism is going to be set to a certain amount of square feet. And so usually 10 square feet or 20 square feet are your most common prisms. And the tree is going to be in or out of your plot based on if you see the tree line back up on itself through the prism. So this is a very good example of it, where this is my tree, but when I look through the prism, the area where DBH would be is distorted. So if it's distorted and it's not on the tree, not overlapping the tree, then it'd be out. But if it overlaps the tree the way this one does, because you can see through the prism here that it, oops, sorry about that, that it overlaps the tree, then that would be in, and so that's a tree that would be counted. So I would do this for every tree that I think would be in my plot, and then I would just simply say if this is a 10 factor prism, that means 10 square feet, and there were 6 trees, I have 60 square feet of basal area in this one plot, and then I would do that for multiple plots. So then what's the other part of it? Well, we got to get the basal area for the tree. So what we have to do is then measure DBH of all those trees we decided were in, and that way we can that's another way that we can figure out basal area as well. So either you have a prism or an angle gauge that tells you, okay, 10 square feet, good. Or if we're doing a different type of plot measurement, which these would be fixed radius plots, you would just measure the DBH and then we would calculate the basal area just using a formula that we put in an Excel spreadsheet or in some sort of a cruising program. So there's 2 ways that you can get DBH when we're doing inventory, or sorry, that you can get basal area when doing inventory, either by DBH or by using one of these angle gauges or prism with a basal area factor. And so, not trying to ruin the whole idea of inventory for you, just giving you a quick example of what that would look like in a plot. So, let's take the fixed radius example first. So we're going to do a 1/10 of an acre because that's a nice easy measurement. So it's an easy plot for us to do to get a good number of trees, and then we would just multiply it by 10 to get it on a per acre basis. But so it looks like in here, if we looked at our trees, we had 1, 2, 3, 4, 5, 6 trees come in here. So what we do is we go and measure the DBH of each of these trees, and we get each of those individual DBHs. We use our formula, okay, and that tells us we had 4.193 square feet if we sum it all up, but it's a 1/10 of an acre plot. So to get it on a per acre basis, we just multiply it by 10, and that would mean if this one plot was representative of the whole area, we'd have about 42 square feet per acre of basal area. But what's going to be more interesting and what we'll talk about as we go into inventory is rather than doing one plot, if we have an area where we got a lot of variation and a lot of differences, we're going to do a bunch of different plots. And then we're going to do this over and over again and then put that all together and be able to get a really good idea of what's going on out there in the forest. But basal area is going to be one of our key measurements. And so it's really important to just understand this basic idea that we really want to know the size of the tree, because the size of the tree tells us how much wood is out there. And then the size of the tree will also help us dictate our management decisions in terms of how many trees should we take out, because if we take out how many trees, how much crown will we take out, and how big of the trees will we take out, how much ground will we open up, and all that comes down to the size of the tree. And the best, quickest, easiest way for us to figure out the size of the tree is basal area.